In this video, we'll continue to look at linear rod, and this is a question from Edexcel M2 January 2006 question 6. So in previous videos, we have introduced the method or the routine for answering these questions. So we do a force diagram, we resolve vertically, we resolve horizontally, and then we take moments about the point A. So here we're told that the system is in limiting equilibrium. So straight away we know that our friction will be maximum friction. So we can put mu RA right here. We will have our reaction force or contact force right here. We can label that RA. We're going to have a reaction force or contact force at B. We can label that RB. We're going to have, the ladder has a weight of W, so this is weight rather than mass, and we are modeling it as a uniform rod, so weight will act halfway down the length of the rod. So we're going to have W here, and then we're going to resolve in this particular manner. Similarly, we're told that a weight of 4W is placed at the point C. So we're going to have 4W here, and then we will resolve as follows. So theta is there. This is also be theta. This will also be theta. We can resolve RB in the following fashion. So that will be the right angle. And then we can show that this angle here will always be the same as this angle there. All right, so we know that the coefficient of friction is mu. We know that tan theta is equal to 2. So we can draw a triangle here. Tan is opposite over adjacent. So that's 2 over 1. Therefore, this will be root 5. So cos theta is equal to 1 over root 5. And sine theta is equal to 2 over root 5, and then we have mu. Okay, so we have included all of the relevant details from the question. We're now going to move on to step 2, which is to resolve vertically. When we resolve vertically, our up forces are going to sum to our down forces. So our up force in this case is RA, and our down forces will be W plus 4W. Okay, so that will give us 5W. So that will be called equation 1. All right. So next step will be to resolve horizontally. So when we resolve horizontally, the forces acting to the left will equal and sum to the forces acting to the right. So mu RA will equal to RB. That will be equation 2. We know that RA from the previous step is the same as 5 times W, and that's going to be equal to RB. So that's equation 2. Equation 3 will be formed when we take moments about the point A. So when we take moments about the point A, it'll be the distance from the pivot point to where the perpendicular component of force is acting against the rod. So that will be 2A times the perpendicular component of this will be W cos theta, and cos theta is 1 over root 5. So 1 over root 5 times W, plus the distance from A to C is 3A, the perpendicular component of 4W is 4W times 1 over root 5. So that would be 3A times 1 over root 5 times 4W. And then that will be equal to the distance away from A to B times the perpendicular component of RB. So this is RB cos theta, that will be RB sine theta. So it will be 4a times RB sine theta, and sine theta is the same as 2 over root 5. So we can simplify and then solve for RB. We know that we can divide through by a, divide through by a. So this will be 2 over root 5 W plus 12 over root 5 W is equal to 8 over root 5 RB. And of course, the root 5s will cancel out. So we're just going to be left with 2W plus 12W, which is 14W. So 14W is equal to 8RB. So RB is equal to 14 over 8W. So that is 3. So we can we can substitute that into equation 2. So mu times 5W is equal to 14 over 8W. And the W's, of course, will cancel out. That will cancel out. And therefore, what we're going to have then is mu is equal to 14 over 8 times 5, which is 40, which will be 7 over 20, which is equal to 0.35, as required. So in the second part of the question, we're told that a second load of weight, KW, is placed at A, and the load of weight 4W that's here is going to be moved to up the ladder to B. The ladder is modeled as uniform rod, and the loads are modeled as particles, so acting at a given point. Given that the ladder and the loads are in equilibrium, we want to find the range of possible values of K. So what we're going to do is we're going to add a weight right here, move this right here, and then we're going to adjust the diagram. So I've done that adjustment previously. So the weight remains here, the weight of the ladder, and then of course the 4W moves here. What I've done is I've resolved that right here, and I've also resolved RB here. Notice for this is the first example we have actually resolved RA, and then the weight here is also resolved. So in the manner presented here. We recall, of course, that cos theta is equal to 1 over root 5, and that sine theta is equal to 2 over root 5. And then we recall mu is equal to 0.35. So given this new diagram, what we're going to do the same things as before. We're going to resolve vertically, we're going to resolve horizontally, and then we're going to take moments about the point A, and that is A, and that is B. So when we resolve vertically, we're going to have up forces summed to down forces. So we're going to have the up forces RA, and then the down forces KW plus W plus 4W, which is 5W, and that will be equation 1. Then we're going to resolve horizontally. So the forces acting to the left, which will be friction, is going to sum to the forces acting to the right, which in this case is going to be RB. And then that is equation 2. Then we're going to take moments about the point A. So moments about A. So we're going to have, this is going to be halfway along. So again, it will be 2a times by w cos theta, cos theta being 1 over root 5, so w over root 5. Then that will be that will equal to that will be added rather to 4a times by 4w cos theta, which is 1 over root 5. And then that will equal to the anticlockwise turning effect, so that's 4a times by rb sine theta. So that's 4a times rb, and then sine theta will be 2 over root 5. So 2 over root 5. We can simplify that. So this implies the root 5s, of course, will cancel out. So we have 2aw plus 16aw, which will be 18aw. And then that will equal to 8a rb. So when we rearrange, we're going to get the a's will cancel out. So we're going to get 18w over 8 is equal to rb. And then that can be simplified to 9 over 4. So 9 over 4w. So simplified version for equation 3. So that tells us, therefore, that friction is equal to rb, which is going to be 9 over 4w, which is going to be less than or equal to mu times ra. So 9 over 4w is going to be less than or equal to mu we had worked out in the previous part to be 0.35 times ra. We know that ra is equal to this. So kw plus 5w. All right. So the w's, of course, will cancel out. So we're going to have 2.25 is less than or equal to 0.35, and then that is k plus 5. So here, continuing to get an inequality for k, we're going to divide by 0.35, and then we're going to subtract 5. So that means, therefore, that k is going to be greater than or equal to 2.25 over 0.35 minus 5. So if we type that into the calculator, we're going to have 2.25 over 0.35 and then take away 5. All right, so k is going to be greater than or equal to 1.43. So if we were to write this in exact form, we would have k is greater than or equal to 10 over 7. 3 significant figures.